right, these are the notes for lesson 2 of unit 9, building polynomial functions. So let's do a little bit of review. Let's kind of ease into figuring out how we're going to build these functions. It says write the following cubic polynomial in factored form. We're going to do that by factoring, and we're going to group. The reason we're going to group is because there are 4 terms. So when you group, remember you put the first 2 terms in a set of parentheses and the last 2. You look for a GCF for each group. The first group looks like it has an x squared in common. So we would have x squared times x plus 2. And the second factor has a negative 9 in common. And when I divide that out, I get an x plus 2. Well, when I rewrite this, I get x squared minus 9 and x plus 2, which normally is factored form. But take a closer look at the factor on the left, x squared minus 9. I can actually continue to factor that. We need to factor it all the way by difference of squares. To do that, we take the square root of x squared, which is x. The square root of 9 is 3. And remember, we put a plus in one and a minus in the other factor. And then our other factor of x plus 2 comes down. All right, well, that would be our fully factored form. X plus 3, x minus 3, x plus 2. So now to state the zeros, or the roots, of this cubic polynomial. Well, to do that, remember, you technically use the zero product law. So you would set each factor equal to 0, and then solve for x. The first one, I subtract 3, so I get a root at negative 3. The next one, I have a root at positive 3. And then a root at negative 2. Right, this cubic polynomial, we know degree 3 has 3 roots. It looks like it has 3 x-intercepts, and that's where they are. What is the end behavior of this graph? Well, if you're not sure, why don't we go ahead and graph this here. So x cubed plus 2x squared and then minus 9x minus 18. All right, so here's my graph. Looks like the end behavior has one arrow down low, one arrow up high. It kind of looks like, I'll sketch it right here. Kind of looks like this. So my arrow on the left is going down towards negative infinity. The arrow on the right is going up to positive infinity. Now it says, what's the y-intercept? Well, let's look here. Let's scroll, scroll, scroll. We can click on it. The y-intercept looks like it's at negative 18. And if I look at my equation, I should notice that the y-intercept is the constant that was on the end of the standard form. Same as a quadratic function. If I have degree 3, the maximum number of turning points is 2, and I can see that on my picture. If I zoom out here, there are 2 terms. All right. Now let's talk about building. You should have noticed, I guess going back, that from the factored form in the box here, the roots, these zeros, were the opposite of all the numbers that were in the factor. I had a positive 3 and a negative. The negative 3 gave me a positive, and so on. So if oh, that's not good. There we go. So if I want to go the other way, I need to remember that fact. Here's to state the x-intercept. So it looks like I have one x-intercept at negative 3, and then another x-intercept at positive 1. Now, the factors that give me that x-intercept are the opposite of those signs. So my factors are in parentheses. Each factor is going to get an x, and I would do the opposite sign. So x plus 3 gives me the root of negative 3, and x minus 1 gives me the factor of positive 1. Now to get standard form, I'm going to multiply, distribute. So I'd have x times x, which is x squared, minus 1x, plus 3x, minus 3. Now, in order to actually be in standard form, I have to collect like terms. So I end up with x squared plus 2x minus 3. And that will be your standard form of the polynomial. If you're not sure, I'm letting you use a calculator in this unit. If you're not sure if you did things right, graph it on Desmos. Let's graph x plus 3 times x minus 1. When I graph that, this graph looks a whole lot like the one I had. The roots are in the same spot. Even the turning point was at -1, -4. I can also graph my final answer here. X squared plus 2x minus 3. It graphs right on top of the original factored form, so you know that you wrote standard form correctly. So check your work. That took less than a minute, probably less than 30 seconds to do. All right, let's keep working with equations here. I have a factored form. I have -x times x minus 3 times 2x plus 5. First it says state the zeros. We've been doing this when we did multiplicities. The first root, -x, gives me a root at 0. Right? If you needed to, you could set -x equal to 0, divide by -1, 0 divided by -1 is 0. The next root, x minus 3, that gives me a root at +3. And this last one, 2x plus 5, I'm going to set it equal to 0. I would subtract 5. 2x equals -5. Then divide by 2. So that root would be at -5/2, or that's -2.5. Now it says write that equation in standard form. Now, to write something in standard form means that I need to get rid of the parentheses. So what I have, I'm just rewriting the original. I want to get rid of these parentheses. But I can only multiply two things together at a time. So my suggestion and my trick to make sure that we don't mess things up is I always start on the right. I'm going to multiply the two factors on the right. I'm going to ignore the -x right now. I'm just going to leave it in front. I'm not going to do anything with it. And I'm going to multiply everything on the inside of my parentheses. So I have 2x squared plus 5x minus 6x minus 15. Now what you can do now is distribute the -x into each of the 4 terms, and then we'll collect like terms. So I'll have -x times 2x squared is -2x cubed minus 5x squared plus 6x squared plus 15x. And you can go ahead now and combine those like terms. I'll write this down below. -2x cubed plus 1x squared plus 15x. And that would be, that would be your final standard form. Now, just like we did in the last column, you can check your work. Type the original function in, -x times x minus 3 times 2x plus 5. All right, that's your polynomial. Now, if I type my standard form in, -2x to the third plus x squared plus 15x, my graph is exactly the same. So I know that I wrote standard form correctly. If you forgot, like say you forgot the x on the end, you would see that your graphs would look a little bit different here, so you know you'd made a mistake. Okay, check your work. Now, what's the maximum number of, classify according to the degree? Part C. Degree is 3, so it's called cubic, and it will have a maximum of 2 terms, which if I look at my picture here and zoom out, my graph has 2 terms. And then the end of behavior, well, this graph has a negative trend. It starts high, so it starts at positive infinity and went down to negative infinity. How could you have predicted the end behavior before putting the equation in standard form? Well, you could have counted the multiplicities. 1, 2, 3 of them. I would have known that it was odd degree, and I could have figured out what the picture would have looked like. All right, flip your paper over, number 3. We're given a picture, and we're going to write the equations of this graph. The graph at the right has 1, 2, 3 turns. So the least degree of this polynomial is 4. One more. The graph seems to have 1, 2, 3 unique or different x-intercepts. They are at x equals -2, 0, and 3. Now, the arrows are both going down, which means that the leading coefficient will be negative. So So here's how we're going to be very careful. We're going to write factored form and then standard form of our graph. The factored form is going to have a bunch of parentheses. Now the first thing is, I said my leading coefficient had to be negative, so I have to start my equation with a negative. Let's go through and write our factors. At -2, the factor is going to be x plus 2. I'm going to leave a little space. I'm going to write a factor, opposite sign, x plus 2. At the root of 0, that factor is going to be an x. I like to put the x in front. Now look at the graph, though, at x equals 0. See how it bounces off the axis? We learned back in investigation 2 that when I bounce off the x-axis, that root has a multiplicity of 2. So I have to write negative x squared. Finally, at the root of 3, the factor is going to be x minus 3. Now let's put this into standard form. So I take my factored form, and just like the last problem, I need to multiply two things together at a time. I'm going to start on the right. That's my suggestion. The negative x squared just stays out in front, and you're going to multiply everything on the inside. X times x is x squared minus 3x plus 2x minus 6. And then you can go ahead and distribute the negative x squared. I have negative x to the 4th, which is good. I want a degree 4, plus 3x cubed minus 2x cubed and plus 6x squared. And I'm going to combine my like terms here, the squares, to simplify. Negative x to the 4th, 3 minus 2 is positive 1, x cubed, and 6x squared. Now, let's double check. Again, I'm going to type the factored and the standard forms into Desmos and see if I did this right. So I'll start with my factored form. Negative x squared times x plus 2, x minus 3. That picture looks pretty similar to what I had here. This graph is actually a little bit shorter. Don't worry about that though. The roots look the same, and the shape looks the same. If I wrote my equation here, where did I put it? Negative x to the 4th. And then plus x cubed. And plus 6x squared. I have the same graph, so I know I did things right. All right, let's look a little bit more at factored form. 2 more problems, then you'll have some practice. All we're going to write is factored form, not even standard form. The reason we're just doing factored form here is, 1, there's a lot of roots. It would take a long time to multiply these out. And also because I have some goofy looking roots. Here on the left example, I give you the function notation. Oh, that came back. F of 2/3 equals 0. Now the thing you need to remember is that the number in the parenthesis is always the x value for function notation. So what they're actually giving you is the x-intercepts right here. They're telling you that there's an x-intercept at 2/3, an x-intercept at -5, positive 5, and 4. So our factored form is going to mostly be the same. Now I'm going to come back. This is a special case right here. But the other 3 are going to be what we've been doing. So we'll have a root at x plus 5, a root at x minus 5, and a factor at x minus 4. For the goofy guy that's a fraction, to write x minus 2/3, that's not technically correct. We don't really like factors that are fractions. Yeah, it's kind of right, but it's only like half right. Right? We want integer coefficients. That means whole numbers, not fractions. So what we end up doing here is you take the 3, the denominator of your fraction, and you scoot it up in front of the x. So your factor would be 3x, and then the opposite of the numerator, minus 2. So you're still getting the opposite sign, but the denominator is popping up in front of the x. The degree of this polynomial, you would count the multiplicities. You would have 1, 2, 3, degree of 4, which means it's quartic, and it would have at most 3 turning points. All right, the next one here, roots. I gave you the roots, or the x-intercepts again. So at -5, you have a factor at +5. Here I have x equals a half. So remember that denominator scoots up in front of the x, 2x, and I take the opposite sign, -1. I have a root at +1, so my factor will be -1. And the last root is just at x equals 0, so that's going to be the factor of x. You can put it on the end. I tend to like to put the factor of x out in front, but it doesn't matter where it goes. This polynomial, again, oh, I missed one. I'm sorry. I missed this guy in here. X equals -4/3. The 3 pops in front of the x, so 3x, opposite of -4, so +4. There is a degree of 1, 2, 3, 4, 5, so it's called quintic, and it would have 4 terms. All right, I want you to try the 2 problems on the bottom, and then there's a couple more practice if you need them for this topic.